a stone is dropped from the top of the CN Tower in Toronto, 450 meters above the ground. Given a downward gravitational acceleration of 9.8 meters per second, how long will it take to reach the ground, and with what velocity will it strike the ground? Okay, so we are told that the acceleration as a function of time is negative 9.8 because it's negative because it's downward. So we're thinking of upward vertically as positive and downward as negative. So this has an acceleration that's constant, negative 9.8. And we want to figure out the position function so that we can then figure out what time the position is at 0. So we're given the acceleration. We can take the antiderivative to find the velocity. The antiderivative of a constant is just that constant times our variable, negative 9.8 t, and then plus c. But we're also told that the stone is dropped. That means that the initial velocity, v at 0, is equal to 0. If we had thrown it upward, that would be a positive initial velocity. If we had hurled it downward, that would be a negative initial velocity. But when you simply drop something, that means the moment that you drop it, the velocity is 0. It starts at 0 and then gravity acts upon it. So because we know the initial velocity is 0, we can plug in 0 for t and then set that equal to 0. And we do see that c is 0. That's really nice. So our velocity function is just going to be negative 9.8 t. And then we have to antidifferentiate again to get the position function. That's going to be s of t equals, the antiderivative of t is t squared over 2. And so because we've got that over 2, we're going to have to divide negative 9.8 by 2. That's going to be negative 4.9. Negative 4.9 t squared plus a constant. But we know that our initial height is at the top of the tower, which is 450. So that means s of 0, which is 0 plus d, is 450. So that tells us that the value of d is 450. And so we know our position function is going to be s of t equals negative 4.9 t squared plus 450. So that is our position function. So we've got that far. And we were asked, how long will it take to reach the ground? Well, it reaches the ground specifically when the position is equal to 0. Because in this problem, the position is the height. Starts at 450 meters, and we eventually want to know what value of t makes this 0. So we want to know s of t, which is negative 4.9 t squared plus 450. When is that going to equal 0? Now, I'm going to add 4.9 t squared to move that to the right and also make it positive. So that's going to give us 450 equals 4.9 t squared. Now we can divide both sides by 4.9 to get the t squared alone. That tells us t squared is about 91.84. This is an approximate value. And then to get t alone, we have to take the square root. And when I take the square root of both sides, we get plus or minus 9.583, approximately. Now we're going to throw away the answer where time is negative because this problem starts with us dropping the stone at t equals 0, and we're looking at how long after we've dropped it takes to hit the ground. Doesn't make sense to look at negative values because we don't know what happened before we dropped it. We're only looking at positive values. So in this case, that's going to be 9.583 approximately seconds, because that's time. So it's going to take about 9.583 seconds to reach the ground. We're also asked what the velocity is going to be, but remember, we have an equation for the velocity. The velocity is negative 9.8 t. So v at 9.583 is going to be negative 9.8 times t, which is 9.583. And that gives us an answer of about 93.9. This is going to be measured in meters per second because it's velocity. And so that is very, very fast. So you do not want to drop a stone off the top of the CN tower, because if that hits a vehicle or a person, heaven forbid, it's probably going to kill them. All right, we have solved the problem, but I do want to go back and look at what we did, because I think at a higher level, it's good to have a sense of what we're doing here. So we were given some information about what happened. We know that this is a projectile object, which means it's being acted upon by gravity. And so we know that the acceleration is going to be constant. Since it's metric, it's going to be negative 9.8 because it's moving downward. It's being pulled downward. If this was in imperial units, US units instead of metric, we would use a different number, but we've got that constant acceleration. We know that we can anti-differentiate to get from acceleration to velocity. And we had a constant, but we were able to figure out what that constant was because we knew the initial velocity, because we weren't throwing it upward or downward. We were just letting go of it. If this problem were different and we were told that we threw it upward at a certain velocity, that would have been our initial velocity, and that would have changed the rest of the problem. But anyways, once we know what our velocity function is, again, we can anti-differentiate to figure out the position function. But again, there's a constant there, and so we need a piece of information to help us figure out that constant. And in this case, that was our initial position. We were 450 meters above the ground. So oftentimes with these problems, you're going to be given an initial velocity and an initial position, and you're going to be able to use those to figure out what those constants are. And that gives you your total function for position. You've got an exact function for position. And once you know that, you can use the math that you've already learned to solve problems. We want to know when it hits the ground. Well, the ground has a position of 0, so plug in 0 and solve. We want to know the velocity at that time. Well, we've got a formula for the velocity. We've got an equation for the velocity. Plug in the time, and there you go. So it's really all about taking these antiderivatives, using the information we're given to figure out the values of those constants. And once we have the equation for position, we can pretty much figure out anything we need to. So there you go.